Welcome back to the Let's Code Java channel. My name is Alex and I am a senior Java developer. Today we are building a crucial architectural bridge. We are moving away from writing messy imperative checks and shifting toward the declarative approach. If you ever wondered how annotations like service or value work under the hood in Spring Boot, this video is for you. In this step 4, we will inspect the standard JDK override annotation to understand the basics of metadata, create our own custom annotations to handle geometry validation, and finally we'll build a reflection-based engine that scans and validates objects at runtime. We're stripping away manual logic and moving into metadata. This is what defines a senior developer, the ability to build not just code, but the tools and engines that drive the system. Let's code Java. So first of all, let's take a look in our ordinary class with the override annotation in it. It's placed above the method calculate area that actually was override of our abstract method in our array calculator class. So override means that method declaration is intended to override a method declaration in a super type. If a method is annotated with this annotation type, compilers are required to generate an error message unless at least one of the following conditions hold. The method does override or implement a method declared in a supertype. The method has a signature that is override equivalent to that of any public method declared in an object. That means that this annotation works with compiler. So when compiler sees this annotation, it must check if it's put above the method that has inheritance. If it's not, it's produce error. So if I will put it there, for example, I will see error with the annotations are not allowed here. Let's see what makes this annotation to know where it is. So on override annotation look like this. It's look like Java interface, public interface override with add sign before the interface, and above it, we have two meta annotations, one called target and one called retention. Target annotation has a parameter called method from enum element type, and the retention annotation have also parameter that called source. So let's see what target is, and it is the the context in which an annotation interface is applicable. So in our case, we want to put override annotation above the method. So target is a method. What are the values we can use? Let's see our element type enum here. So it can be type for class interface, field for field declaration, method as we see for method declaration, and parameter, constructor, and other places where we want to put our annotation. So, and retention, in our case, retention has the value of source. Retention means that retention means how long annotations with annotated interfaces are to be retained. In our case, it is source, and that means that annotations are to be discarded by the compiler. So it's right, compiler will see override annotation, and it will check if it exists in class that inherits something or no, and if no, we have the error, and then it will be discarded. What additional values we can see? Let's see in a retention policy. We have source, class, and runtime. Source we already saw. Class annotations are to be recorded in the class file by the compiler but need to be retained by the VM at runtime. That means that the annotation with the class value will be stored in the .class file after compiler compiles our Java file. but when we load our class in runtime, we cannot see them. This is good for all tools that have static code analysis. So they just read our class files and inspect what is in, so they can see the annotation there and see and display you a warning about using your class. And runtime annotations are to be recorded in the class file by the compiler and retained by the VM at runtime, so they may be read reflectively. That means that we can use this annotation in our runtime. So when class is compiled, annotation located in the .class file, and when class is loaded, it's also annotation present, so we can use it in our code along with the Java reflection mechanism. So let's go back to our override annotation and copy these two and try to create our own. We want to create validation mechanism via annotation. So we want to put validation shape annotation before class, before classes that we want to check validation. And we want to create positive dimension annotation for the properties we want to validate itself. This is our attention. So validate shape, I already created empty annotation, validate shape interface. So just copy this one, we copy from override. In our case, target will be type because we want to put it with class name, and our retention will be runtime because we want to actually work with it on runtime. And here we want to define our value that will be error message with some template in it. Dim for dimension must be positive. Okay, this is our message. And we want to create another one. We will call it dim template. Let's temp template, and it will hold our dim values at our actual template, so we can overwrite it lately. And our positive dimension annotation. Also, we want to copy these ones. We want to use it also in runtime, and we want to put it. In our case, it's a little tricky. In our code, we want to use it above methods, but in general, we also want to put this annotation above fields that we want to check. For example, if we have field radius, we want to check that is positive. So in that case, target metadata receive value of type, the value of type element type array. So we can pass number of values here, and we will do it. We want to pass element type field for future usages. And here we want to define value. We want to define value string value like this without default value because we don't know. It can be any dimension that we will choose. And beside it, validating shape annotation, we want to put above our abstract class. So we want to make our successors to see this annotation. For this reason, we have another meta annotation called inherited. Inherited. Let's wait a little for my compiler. Inherited like this. And it means that annotation interface is automatically inherited. That's what we need. So let's go to our classes and try to use these annotations. We have shapes here. We have planar shape that our basic class for all our shapes, and we want to put our annotation here. So we just put it validating shape. Validating shape. Great. Validating shape. So all classes that will inherit from planar shape can also have this annotation. And now we will go to specific one like circle. Circle class extend planar shape, and it defined get a radius that will return the one from our from this one here. So here we want to put our positive dimension here, and we will want to provide the word radius because actually name of our dimension here is radius. In the following way, we can define our square with positive dimension side, and the rectangle we have width and height. So we define here positive dimension width, and here positive dimension height. Okay. In this point, we just use our annotation, but no one actually read it. So if we will run our code, it will be transparent for him. Do we define annotation or no? In order annotation to make difference, we need the class that will actually read these annotations and work about it. So we create class called GeometryValidator. It uses Java reflection mechanism that allow us to know metadata about our class and our objects and call its method. So our validate method will receive any object. In our case, it will be any shape, but we see any object and will return Boolean with the capital B because we want to distinguish between objects is validatable and non-validatable. If object is of type of our planar shape, we can validate it, so we will return true or false whenever it's valid or not. In other cases, we will return null to signal that its object is not validatable, so we don't know how to use it. So if we pass for validate double or date or any other object, it will return null. It will not crash, but it will return null because you can't work on it. So how it's working? We check if object is null, we will return null. We get it class, and we try to get validation shape annotation from this class that we put. If class has no annotation like this, it's not valid for this class. We just return null to signals that we don't know about it. And if it is, we just take our value for our annotation, our message, and we take our placeholder like this. And later we 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 iterate over class declared methods. Actually, we looking for gets, and if we see that method has annotation positive dimension, so we mark that validated is true. We see that class already validated, and we try to invoke it and get its value as a double. In our class, it's integer, but generally it can be any number, and double is the largest number we can use. And if number is not positive in our case, so we try to read our annotation, positive dimension annotation, and we try to replace our placeholder dim with the value we receive here. In our case, it can be radius or size or width. So message will be radius must be positive or something like this. We just print it and return false. And we return whenever it's validated. If it's validated, we return true. If not, we return null. So because false, we return already here. So this is our class that working with exception. because our annotations, because our annotation defines at runtime, this line will actually return our annotation, and this one also. If our annotation will be defined as a class or source, this line will return null, and we can't use it. So how we use this class? Later, we have our console shape builder that has build method with create shape in it. And our create shape, we have read dimension method that just read input from console and try to pass it to the integer. If it succeeds, it returns. If it fails, it will run in the loop till the values will be valid. And when it's integer, it will uh, so our create shape. We have shape type, our enum that can be circle, square, and rectangle. In circle, we create circle with the radius. In square, it will be some integer with prompt side, and rectangle, we have two integers at width and height, and they can be negative. So here we use this code. We use shape with create shape, and then in init we call our geometry validator to validate our shape. And we do it in while until init is true. So this build method will not stop until our shape is valid. That means that our dimensions are numbers and they are positive. So this is how we can use it. So let's run it to see how it's work. Main method, create our validator service, calculator, all the stuff like this. Please provide shape. Let's provide circle. Okay, choose radius. Let's choose something like this. Illegal value, please provide positive integer. Okay, let's give him 8. Radius must be positive. This comes from our annotation, so let's give him our best one. The area is, and it's fine. So, and that is for today. As you saw, moving from imperative checks to declarative engine doesn't just make your code cleaner. It makes your entire architecture more scalable and professional. By mastering reflection and custom annotations, you're just peeked behind the curtain of how major frameworks like Spring actually work. If you find this deep dive into Java metadata helpful, smash the like button to support the channel. Subscribe to the Let's Code Java if you haven't already so you don't miss the next steps in our series. And I love to hear from you in the comments. How do you handle invalidation in your current project? Do you prefer manual checks or you're a fan of custom engines? The source code, including the geometry validator we built today, is available on GitHub. Check the link in the first comment. My name is Alex. Thank you for watching, and I'll see you in the next one. Happy coding!